Hello Marauders, here I am under the sea. Today we're going to look at a little bit of 4.6 and we'll learn about the other trig graphs. And today we'll basically focus on secant and cosecant graphs. Okay, so you may have been wondering about these other graphs. We learned sine and cosine. Today we'll look at cosecant and secant. They look kind of funny and confusing, but they're really, really simple. All they are is these graphs upside down. In fact, if you look at the definition, we might remember cosecant is just sine flipped over. And secant is just cosine flipped over. I remember I kind of think of COS, so kind of backwards, SEC, kind of close. And I say it's a sin if you don't have any vowels. So here's how this works. Very simple. And when I say it's simple, trust me, it actually is simple. So imagine you had to graph a sine graph. So I'll just do our basic sine graph. Remember, start here at 0. We go up, back to the middle, down to the bottom, back to the middle. This is normally like 2 pi. This is pi. Okay, if you have to do sine upside down, in other words, 1 over sine, or as we just call it, cosecant x, all you do is turn the graph upside down. So what you're going to do is take this graph and turn them upside down. In other words, just go like this. See that? And where this is 0, well, can you do 1 over 0? No, that's an error. So this is an asymptote right here. Same here. This is at 0, which is an error. So anywhere the graph touches 0, you draw an asymptote. And then just draw this guy upside down. So it gets really, really close to where the 0 is. That's it. That's pretty simple. We'll look at it in Desmos for a moment. But here's the cosine. Cosine, remember, starts at the top, goes down to 0, the bottom, back to 0, and back up. So if you wanted to do cosine upside down, 1 over cosine, we just call that secant. Okay, secant x. So if you had to do the secant graph, this was the cosecant, this is the secant. So once again, turn upside down. Find where it's 0. That's an asymptote. This is an asymptote right at 0. So just take this and draw it upside down. It's like, oh, let's take him, turn him upside down. Turn him upside down. Of course, you're like, kind of looks funny, but remember, you could keep going. You could keep going with this graph. You could just keep going on and on. And then, of course, you could draw some more here if you want. Just put asymptote right at 0, and etc., etc. That's it. Well, that was pretty easy. Check it out in Desmos. Okay, here's Desmos. I put in sine of x. There's one wave. Of course, I could zoom out and see it over and over and over. I just kind of zoomed it in, tried to get it to 0. Let's see if we can get it right. That looks like one period, one cycle. Here's sine, so upside down is cosecant, and there it is. See, just upside down. I could zoom out, and then kind of looks funny, doesn't it? So you just take them, flip them over. Okay, likewise, we could do cosine, cosine of x. You notice he's just a little bit off, and then we'll do him upside down. Secant x. And there's so you can turn these off by clicking off the colors. But there it is, upside down. If you want to look at one wave, get it right where 0 is. Here's 0. There you go. Right where it starts. And you can just try to get one wave of the cosine, and you see part of it. But sometimes people just draw a lot of them. That's it. Hope you enjoyed it. Tomorrow we'll look at the other two, tangent and cotangent. A little more to doing that, but once again, not too easy. You can do a little bit of 4.6. This is kind of the second half. See you guys tomorrow.